Hello everyone. We all know that how important data structure and algorithm is in the IT world. Data structure is a very important for getting jobs in the FANG companies. In data structure, linked list is very important concept. Lots of complex problems are solved using the linked list. So today I'm going to discuss about linked list. So what is linked list? Do you have any idea how it works? Why it is used? All this I'm going to discuss today. We will also implement linked list in Python. So let's begin. So now we are starting linked list. So before going to the linked list, first of all, we have to know that what is list. So list is basically a linear collection of data items. Okay. So list is what? It is a linear collection of data items. The data items can be anything like we have given some examples in the screen that list of marks. Suppose I am a student and why I want that the five subject I want to list down the all marks of each subject. So here I am showing that list of five subject, that is 30, 45, 50, 36, 41. These are my marks of five subjects. So this is a list. So basically this is a data item. Again, list of names. So here first one is Ronit, second one is Sumit, third one is Mahi. So this is the list of names. So up to this, we can see that we have two lists. First is for marks, second one is for names. First one is for marks and that is the list of integers. Second one is list of names. That is we have stored character array. In C language, we can say this is a character array. In Python, we can say this is a list of strings. Okay. So all these two lists are of homogeneous type. That is all the data items in this list are of same type. That is in list of marks, it is of integer type. In list of names, it is of string type. We can also have heterogeneous data element, like we want to store a list of students. Suppose in a college we have multiple number of students. I want to store all students name, his marks and his address. So here I am showing a first list. You can see that is written Ronit, that is name of student. Then second one is 500, that is the total marks of that student. And third one is Kolkata, that is the address of this student. So these three fields as a whole represents single student. So this is the data of single student. This is called data item. Second one is the data of student number 2. Okay, student number 2, that is Sumit, that is, and his marks is 300 and his address is Delhi. So this is a heterogeneous data elements, because in this list first element is of string type, second one is of integer type, and third one is of string type. Okay, so in C language we cannot store heterogeneous data element at a single location. Okay, we have written we have learned about array there in C language. In array, what happened? We can store same type of homogeneous data element. So in C language, if we want to implement this type of operations, then we have to use structure. In C++, we can use structure as well as class. Now we are learning Python. So in Python, we can implement this using class. So now I'm moving to the next screen. That is why linked list. Why we use linked list? Why we not use array? Okay. So first reason is that array elements are stored at contiguous memory location. What do you mean by contiguous memory location? Contiguous memory location means that if my first element is stored at here, then my second element must be stored here, third one here, fourth one here. So the elements will be stored in a linear order. That is, see the screen. If we want to store some numbers which are represented by blue color, okay, that is 1 2 3 4 5 6 7 8 9, okay, and this is my memory. Basically this is the RAM. We know that a program is, whenever a program is executing, all the data, all the variables are stored in the RAM. Okay, it takes memory in the RAM. Here there are so many blocks present in the RAM. The yellow highlighted fields represents that memory location has been fulfilled, that cannot be accessed. Okay, so we have the blank memory locations, this, 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 okay, and so that now we are storing this number. So we have stored it like this. First number is present where at this memory location, then second number is allocated after this, and third one after this, fourth one after this, and so on. So this memory allocations has been done in contiguous manner. Now if we want to allocate these numbers, that is 5 10 15 20 25 30 35 40, how can we store it in this memory? Look, is it possible? How many numbers we have to allocate? 1 2 3 4 5 6 7 8. I have to allocate 8 numbers, so I need 8 memory blocks. So see the memory. Do I have 8 memory blocks? Yes, we have more than 8 memory blocks, but as we are storing it in the array, so we have to check whether 8 memory locations are present at contiguous manner. So see this 1 2 3, here only 3 elements can be allocated, so I cannot allocate here. Okay, also same here, it cannot be allocated, not here also, not here also. We can see we cannot store these 8 numbers in the memory location, but I have that space for 8 numbers that can be stored. Okay, so this was the advantage of array. This problem is overcome by linked list. Also, what is another difference, or you can say disadvantage of array? That is, just remember in C language what was the syntax of declaring an array. What was the syntax? Int, then array name, and then we have to mention its size. Now tell me, what number of what will be size of my array? Do you know at this time? No, you don't know that how many numbers I have to store until or unless it is given. Suppose I have given 5. Okay, I have given 5. If I want to store 2 numbers, then it is fine. We can easily store 2 numbers in the array of size 5. Okay, now suppose we have to enter 10 numbers. We cannot allocate in this array. At that time, we have to extend this array, but array cannot be extended. Array cannot be extended. Its size is fixed. So this is another disadvantage of array. Okay. Now, this problem is overcome using linked list. So what is linked list? See, in linked list, elements are stored in discontinuous manner. In linked list, elements, or you can say numbers, or you can say data, are stored in a discontinuous manner. That means it is not necessary that all the numbers of same data set will be allocated in linear order. Okay, we have space in the memory, we can allocate it, and then we can link each data with each other. Just see this. We are storing the first data set, that is 1 2 3 4 5 6 7 8 9. We had this space in linear way, so I have stored it. Okay, basically I know I don't store it, OS stored this. Okay, so OS, so that there are space in continuous in line by line order, so OS stores it. Now for the second number set, that is 5 10 15 25 30 35 40, we don't have linear blocks. Okay, but we have space in our memory location for these 8 numbers, so it is stored here. It was empty, 5 is stored here, then 10 is here, 10 is stored here, and this 5 is linked with 10. So we have stored 2 numbers. Okay, we have stored 2 numbers, basically a list of numbers. Okay, so these 2 numbers are list of numbers. We are linking these 2 numbers. That's why this is called linked list. Getting my point? Now the third number, that is 15, it is stored here. So it will be stored here, and this 15 will be linked to 10. Again 20 is allocated here, this will be linked by this 15. Then 25, it is stored here. Now this 25 will be linked with this 20. Then 30. Now 25 is linked with 30. Then 35. So it will be also linked with 30. And at last we have 40. And it will be linked with this. So in this way, we can store numbers in our memory location using linked list. I think this is clear. Now, as I already told you that I will implement this linked list in Python. So we have also see what is the disadvantage of Python list. We have already inbuilt data type in Python, that is called list. Don't confuse between that list and this linked list. Both are different things. Okay, so disadvantage of Python list. What is the disadvantage of Python list? Let's see. Suppose I have created a list with two numbers, that is 2 and 3. So in memory location, it is allocated in this way. And remember one thing, linked list is Python list also stores the memory data in memory in sequence. Okay, because here there is a concept of indexing in Python list. So suppose in 0 index I have stored 2 and 1 index I have stored 3. Now I am appending 4. Okay, so this can be easily appended in list. That is, another memory block is created and it is linked with this. Okay, no problem. Now when pop operation is done in Python list, then what happens internally? See this. First of all, pop 0, I have written list dot pop 0. That means the 0th index element of this list will be popped. So what is the element at present at the 0 index? It is 2. So 2 is popped. Now the 0 index has become empty. But if you print again the list, then in 0 index you can see it is 3. How is it possible? 3 was at first position, index number 1. But why it is showing at index 0? The reason behind this is that after popping the element 2, all the elements of this list are shifted left. All the elements of the list are shifted to left side. So as this shifting is happening each time whenever we are popping a list element, it is a necessary task now. So it will must consume some time. Now again we are inserting 5 at 0 index. So at 0 index it was 3, but after inserting 5 at 0 index, now the all the element will be shifted to right side. So this is also unnecessary task. I am inserting one element, but all the elements of the list are shifting. So in a small list, it will not affect such. But suppose there are thousands of millions of number present in a list and we are inserting one number and shifting of thousands of millions of numbers happens. So how much time it will consume? That will consume huge amount of time. So this is also a disadvantage of Python list. This problem can also be overcome by using linked list. So what is linked list? I hope you must have get the idea why we are using why we will use linked list. So see, linked list is a linear data structure. We can store data in linear way. Okay, unlike array, linked list elements are not stored at contiguous location. Okay, unlike array, linked list elements are not stored at contiguous location. We have already seen that if I want to store 8 numbers and we don't have 8 blocks in contiguous manners, but I have 8 space in memory. Okay, so we can store that and link each other. It is a sequence of data elements which are connected via links. As I told you, we first we allocate each numbers in the memory and then we will connect each numbers via a link. Okay, each data item contain a connection to another data item using the reference. What does it mean? So I am saying that each node will be, or each number, okay, each number will be connected with each other via link. So what does this link means? Basically, this is the reference. Okay, whose reference? The reference of the memory address at which the number will be stored. In C language, we called it the address of the memory location that is manipulated using the pointer. In Python, there is no concept of Python. So in Python, we can use reference to access these memory locations. Got it? Now, applications of linked list in computer science. What is the applications of linked list in computer science? We can implement stack and queue using the linked list. We have already learned about stack and queue previously. So stack and queue can be implemented using the linked list. See, wherever we use array, we can implement that thing in the linked list. Okay, because linked list has been introduced to solve the problem of the array. Now, second one is implementation of graph. We can implement graphs using the linked list. Now, dynamic memory allocation, that is list of free blocks in RAM. Dynamic memory allocation means, see, linked list don't waste the memory. Okay, in which manner? In that manner that if I don't know the size of array and I don't know how many numbers you will give me to store. So what will I do in that case? If I create an array of size 1000, okay, and you give me just two numbers, I have allocated the memory location for 1000 elements and you have given me just two numbers. So just think about the wastage of memory. Okay, so linked list, what do? Linked lists mechanism is that whenever you will give me a number, I will create a memory dynamically and then store that number in that memory location and then link with the original list. We will see in the implementation. Okay, then fourth one is representing sparse matrix. Sparse matrix, we know that a matrix is called sparse matrix when maximum of the elements of this matrix containing 0. So this can be implemented also in the using the linked list. Then fifth one is manipulation of polynomials. We can also solve the polynomials using the linked list. Now let's come to some real life examples or real life applications of the linked list. In real life, where linked list has been implemented, we all uses internet. Okay, we spend our lots of time on the Google, on the internet, web browsers. There we saw a previous and next button. Okay, to go to the previous tab, to go to the next tab. Have you ever think how it works? It works using the linked list. Linked list has been implemented there. Okay, in mobile phones, we view images daily. We click the selfie and then view in our phone. Okay, and by the sliding we can go to the next image and go back to the previous image. Linked list is also implemented there. Okay. GPS navigation system, it is also linked list can be used there. Then file system in our computer, in our mobile phones, okay, that are also can be implemented using the linked list. What happens there? There are sequence of directory, each directory is linked with each other, okay. Then the very vital thing which we all do in our daily life in computer, that is undo and redo functionality, that is also can be done using linked list. Now, how to represent a linked list, how linked list is actually is, okay. So first of all, we will see that a terminology, that is node, okay. We are saying data item, data item, data item. What is the data item? Okay, or data element. So in linked list, each data element, okay, each collection of data element are called node. Okay, suppose we have 5 balls. Suppose we have 5 balls. In each ball, we have some water, we have some color, okay. In each balls, we have some water and we have some color. So water and colors are data element, a data. So, and each ball is connected with each other. So in this example, water and colors are the data element and ball is called node, and each ball, or you can say each node, is connected with each other, and a collection of node makes a linked list, okay. That is written here. Each node is connected with each other. We can see each ball is connected with each other. Each node is divided into 2 or more parts. In linked list, each node can be divided into 2 or more parts, okay. Minimum 2 part is necessary, okay. Why it is necessary? See this next line. So in each node, one part must contain some data, one part must contain the address or reference of the next node. So that's why I said that minimum 2 parts are required in linked list. There can be more than 2 parts, okay. If we want to store 2 or more than 1 datas, okay. If we want to store more than 1 references, so that can also be done, okay. But remember one thing, first of all we will learn about linear linked list, okay. So in linear linked list, we divide the each nodes into 2 parts for our simplicity. Now types of linked list. There are these types of linked list. First one is linear linked list, second one is circular linked list, third one is doubly linked list, fourth one is circular doubly linked list, and fifth one is header linked list. In these types, first 3 types are very important, okay. First 3 types are very important, and among these 3 types, this one is very important, because if you understand linear linked list implementation, then you can implement by yourself the circular linked list and doubly linked list and circular doubly linked list, okay. So let's starting with the first type, that is linear linked list. What is linear linked list? In a linear linked list, each node is divided into two parts. Okay, each node is divided into two parts. First part contains the information of the element, that is the data. Suppose we are storing 10 numbers. We want to store 10 numbers. We want to create a linked list of 10 numbers. Okay, so for storing the number, we have to divide a node into two parts. First part will contain the number. Second part, called the link field or next reference field, contains the reference of the next node in the list. And second part of the node will contain what? It will contain the reference of the next node or the upcoming node. Okay. Now, whenever a linked list is created, it always refers to the first node. This is very important. Suppose we are storing three numbers. First number here, second here, third here. Okay. So we have created a linked list of three numbers. How can I access this list? Will I access from here or here or here? So that's why whenever we create a list or linked list, it always refers to the first node of the linked list. Okay. See here, we have created a linked list called head. Okay. And then we are creating some nodes for storing the numbers represented by data. Each node refers to other node which are represented by next. Okay, and each are referenced. You can see the links over there. Okay, so the linked list, whenever we create a linked list, it always refers to the first node of the list. First node. And the last node will refers to none. In Python, we know none is a special type of data. That means nothing. That is none. Okay. If the linked list is empty, then I said now, whenever we create a linked list, it always refers to the first node. Now the question is that if first node is not present, that means the linked list is empty. Then how can it refers to the first node? So in that case, it will refer to the none. If it refers to none, then we will understand that the list is empty. Okay. Now, coming to the operations of the linked list. In linked list, basically we have to implement insertion operation and deletion operation. In linked list, we have to basically do two type of operation, insertion and deletion. Third one is reading operation, that is not so complex. Okay. Fourth one, you can also implement the updation operation. But all that can be done. But the main thing which we have to learn in linked list is the insertion and deletion operations. Okay. So insertions how many types of insertions can be done in linked list? How many types of insertion? Mainly, there can be three types of insertion operations can be done. Then that is first one is insert at the beginning, insert at the end, insert at the intermediate position. Okay. Now in the intermediate position, we can also give the position number that at this position it should be implemented. Okay. Or we can also say that if this number is present, then put this number after that. So all can be done logically. There are so many kinds of insertion operations that can be performed in the linear linked list. So first one I'm going to discuss, that is insert at beginning. Okay. Now, first of all, in the insert at beginning operation, what operations should be happen? See, first of all, we already have a linked list. Okay, we already have a linked list. First address, first node's address, that is 1000, is referred by this head. It has some data. It has the address reference of the next node, that is 2000. So 2000 is this. It also has some data. In its next field, it is none. That means it is the last node of this linked list. Now, what happens if we want to insert a node at the beginning? See the yellow colored node that has been inserted in the first position. So first of all, what operations has been done? 1000 has been overwritten by 7000, which is the address of the new node, and this new node refers to the previous linked list first node, that was 1000 now. So this is done. Now you will not understand at this moment. For better understanding, let's move to the spider. Okay. So first of all, I have to create a mechanism for representing nodes of the linked list. So tell me, is there any mechanism for storing the nodes? No, there are no inbuilt mechanism. So I have to create it. So now we will create a class node. We have written this class node. Then we are defining a constructor. Okay. What will be the data items of the node? It may be a data or next field address, right? I am giving none by a default value, that is none. Then self dot data equals to data, self dot next equals to next. Okay. So I have created a class for storing the information of nodes. Okay. So what will happen whenever we create an object of this class? A memory block will be created. Okay. Which will be of node type. Okay, which will of node type. This will be its object. In this node variable or node class, there will be a field as data and a next variable that will contain the address of the next field. Okay, and by default it is none. Data is also none. Okay, so I have created a node. Okay, now I have to start creating the linked list. So linear linked list, I am defining a class that is linear linked list. Okay, in linear linked list, I am initializing a constructor. In constructor, I am passing nothing, but I have to pass self. Why self? We know in Python, while defining the instance methods, we have to pass the reference of the calling object as its first argument. That's why we are using self. Okay. So I have used self in this. Then what will I do? My next task is to create a linked list. Okay. So I am just writing self dot head equals to none. That means I have created an empty list. I have created an empty list. Now, when we create an object of this linear linked list, whenever we create an object of linear linked list, a space will be generated that will be pointed by this, and in this there is nothing. By default it is none, null, or you can say none. Okay, this is the linked list. Okay, now what will it contain? It contain always the address of the first node, but at this moment we have not created any node, that's why it is by default none. Okay, now we will create a function for inserting a node at the beginning position. Okay, so function to create a node at beginning. Okay, so def insert underscore big self, then the number which I want to input in that node, then colon. Okay, after that what will I have to do? See, I have to do some operations. First one is, suppose I have created a linked list. That means it is none by default. Okay, it is none by default. If I create a node, okay, if I create a node, that means this node will be the first node of the linked list if I connect with this. Okay, and this is also the last node of this linked list because the list is empty. So first node will be the first and last node of the list, right? So as it is it will be the last node of the node. So its next part must contain the none, right? Okay. So this was the first condition, that if the linked list is empty, that means if head contains none, then this new node must contain none in its next part. Okay. Now suppose the list is not empty. The list is not empty. It has some node. Let's suppose it has only one node which have the address 1000. So 1000 will be in the head. Okay. Now if I want to create another node, let's say its address is 5000. So if I want to insert it at the first position, then what I have to do? First of all, I will see what is present in the head. So we can see that head is pointing to the first node. That will be the second node of the linked list after the insertion of this new node. So I have to link this node with this. So I have to put 1000 in the next part of the new node. This 1000 is what? This reference is present in the head variable. This reference will be present in the head variable. Okay, now head is also pointing this 1000. This new node also pointing to this 1000. But what I said, I have to insert at the beginning position. So head must point to this new variable. So this must be done. So 1000 should be removed. So now head is pointing to this new node. Okay, and head is not pointing to this 1000. So this is how insert at beginning operations will be done in the linear linked list. Okay, so first of all, I am creating a node. Basically, I am creating an object of this node. Okay, in its data part, I have to give num. Okay, in its data part, I have to give num. That means I want to tell this constructor of the node class that create these variables, and in its data variable put this number. Okay, there is no confusion here. Next, we have to see what is present in the head variable, and whatever will be present in the head variable, that will be the next part of this new node. So node dot next will be self dot head. Okay, so node dot next will be the self dot head, and self dot head should point to this new node, right? See this code. I'm explaining again. This is very important point. Suppose we have a head. We have head. In head, we have none. Okay. Okay, we have none. That means we don't have any node. Now I created a node. Okay. In its data part, let's suppose I have put it 5. If I created a node, I have created an object of this node class. It must have some reference or IDs. Let it is 500. If I want to insert this, so what I have to do? The linked list is empty. So this will be the first and last node of this linked list. So its next part will contain what? None. Its next part will be contain none. Okay, this will contain none. And to link this head with this node, I have to put its reference into the head variable, that is 5000. This is the mechanism. So this is happening. Node equals to node num. So first of all, I've created a node, okay, with its data part containing 5. Then node dot next equals to self dot head. That means self dot head was containing what? It was containing none. So I have put it here none. Then self dot head equals to none. None means the reference of this new node. Self dot head equals to node. Node means the reference of this new node. It is updated in the head variable. So this is the flow of insertion at the beginning of a linear linked list. So this is the statement. Now we can also combine these 3 statements into the one statement. Okay, we can combine these 3 statements into the one statement. How? See this. We are writing self dot head equals to, okay, just tell me, I'm commenting this all this thing. What I have to do in the self dot head, we have to store the reference of whom. See, we are writing self dot head equals to node. We can write now self dot head equals to node num, right? And its next part we can pass now self dot head. We can pass self dot head at it as its next part. See this. What is happening here? We have head. If my head contains none, okay, this is my new node. Okay, in this new node I am passing 5, and its next part I am passing self dot head, that is none, and then we are storing this whole node into this. So this function has been completed, that is inserted the beginning of the linear linked list. Now I want to display this. I have created a linked list. Now I want to display whether it is inserting or not. So let's write a function to display link, display the linked list. Okay. Okay. Display. Now I have to write the display function. Okay. So what will be inside this display function? What will be inside the display function? We have to traverse each node from the head up to the end node, right? And then we have to print the data part of each node, right? We have to print the data part of each node. Okay, so let's write it. First of all, I have to, from where I will start? I will start from head. Okay, So I am writing current node. I am declaring a variable current node equals to self dot head. Current node equals to self dot head. So see what is inside the head variable. 7,000. If I write current node equals to self dot head, that what will be inside the current node variable? 7,000. And what is 7,000? It is the reference of the first node, na? 7,000 is the reference of first node. That means the current node will refer here. Current node will refer here in the first node. Okay. So as I told you, what I have to do, I have to traverse each node and print the data part of each node. Then up to when? Until the last element. And how can we check the last element of the linked list? We already know, if the next part of any node contains none, that means it is the last node of the linked list. So I have to check. First of all, I go to current node. Okay. So here I am printing the data of this current node. Then I am going to 1000. Next part is containing 1000. That is the reference of the second node. Now I have come here. This control moves here. This data part's also printed. This 2000 is here, so my current node pointer will move here. Its data part also be printed. Then we can see that here it is none. It is none. That means it is the last node. I have reached the last node, and I have printed all the values of the list. So simply I will break the. I will terminate the executions. Okay. So from current node up to, we will go up to when? While current node. Okay. While current node is not none. Current node dot next. It's next part now. Or you can, first of all, if you do current node dot next, then that means current dot node dot next. If it contains none, okay, that means it will not be printed. But we don't want that. So we have to check current node is not none. What does it mean? Suppose if the list is empty, that means current node will point to none, because head contains none. If I write current node equals to self dot head and head contains none, that means current node points to none. So how it can be printed? Okay, so we have to check the condition, that is current node is not none. If it is true, then simply put or print current node dot data. Okay, and end this with this, and after this print none. Okay, so this is the function to display a linked list. Now we have written two functions. First of is for inserting at the beginning. Second one is for displaying the list. Now we are going to write a menu driven program. Okay, so first of all, I am writing link equals to linear linked list. I am creating an object of this linear linked list. That means I am creating a linked list. Simple. I have defined a class for linear linked list. Now I have to access. If I want to access this, I have to declare an object of this class. And I have written the name of the object as linked. Okay. As I have declared the object of this linear linked list class, the init block will be executed. Cell.head contains none. Okay. Now, while true, print 1 to insert at beginning. Insert at beginning to display. Press 2 for displaying the list. 0 to exit. Okay. Now choice. Int input. Enter your choice. Okay. If ch equals to 1, then what will happen? I want to insert at the beginning now. So what is the argument of this insert at beginning function? We have to pass a number, right? So link dot insert beginning, and then we have to input a number. So I am writing enter a number you want to insert. Okay, enter a number you want to insert. Okay, elif if ch equals to 2, then link dot display. Elif ch equals to 0, then break. Okay, so I have written a small management program. Okay, now we have to run this. Now I have to give my choice. First of all, I'm seeing I want to display the linked list. You can see it is none. It is printing none. That means the linked list is empty. Now I want to enter 10 at the first position. Okay, there is no error. Now see what happens. It goes in the infinite loop. That means we have some error in the display function. So I have to terminate the execution of this program. So the execution of the program has been terminated. Now see what went wrong. In the display function, we are checking while current node is not none. Then we are printing, no problem. Now say me, are we going to the next node? No. Why? Because I haven't written the statement for traversing the list. So I have to traverse the nodes. So for that, I have to write current node equals to current node dot next. Okay, current node equals to current node dot next. That means I am present. I have three nodes in a list. Okay, I have three nodes in a list. First, second, and third. Okay, suppose I am here. Okay, this is current node. So the data part has been printed. Now I have to move to the next node. From where I will go to the next node, current node dot next. If I go there, then I will reach here. Okay, this is the thing. Now run the code again. First of all, in display none. Okay, first I'm entering 1 to insert at the 10 at the beginning. Now displaying the content, you can see 10 has been inserted. Now again I am inserting 20 and displaying the content of the linked list. Then you can see 20 has been inserted at the beginning position. After then it is 10, then none. I am again entering a number 25. It is again inserted at the first position. Okay, so my insert at beginning function is working properly. Display function is also working properly. Now we will write a function or function to create a node, function to create a node at end. Okay, so insert end self num. Okay, so first of all, create a node. Go step by step. I'm creating a node. Okay, in inserted and what can be happen? There can be two conditions. First one is if head is empty, if head is empty or head is not empty. Here head is empty, here head is not empty, it has some list of element. Okay, so there are two cases. First case, if head is empty, then simply execute it like inserted beginning function, which we have done already. And if head is not none, that means a list contains some numbers, some nodes. Then we have to go to the last node of the list, and then we have to link the new node with the last node. Okay, suppose we have this list of nodes and we want this node to be linked with this, then we have to go here to link this. Now how can I go here? By traversing each node one by one. Okay, so let's writing the code. That is, if self dot head is none. Okay, if it is none, then self dot head equals to node. Okay, if self dot head is equals to none, then self dot node equals head equals to node. That means if it is none, head is none, then just link this. Okay, now if head is not none, then go to the last node. Okay, now I have to go to the last node. So how can I go to the last node? how will I understand that I have reached to the last node? If I check that if the current node at which I have present now, if its next part contains none, that means I have reached at the last node. So here current node dot next is not none, then current node equals to current node dot next, and by this I will reach to the last node. Okay, and current node dot next will be the new node, and this is how the insert at end function will work. So let's check it. To insert at end position, if ch equals to 3, then link dot insert and int input, enter a number you want to insert. First of all, I have to terminate the execution of this code. Now I am running the code again. First of all, I am displaying the content. It is none. Now I am checking the inserted end function. I have to check the inserted input function, right? I am entering 3, entering 5. So 5 will be inserted at end position. Okay, and as at the current moment the head is none, so it is the first, it will be the first element. See, it is the first element. Now again I am inserting, let's suppose 2, then 5, then 2, then none. See, so it is also working, right? Now another function is function to create a node at nth position. Nth position. Okay, now I have to create a node at nth position. That means I have to give a position number to insert a number at that position. So def insert nth self comma position then number. Okay, then I'm creating a node. Okay, now I want to create a node at nth position. So what will I have to do? Suppose I'm going to the presentation sheet, insert at end, insert at nth position. Look this example, you will understand clearly how insert at nth position works. This is first position, this is second position, this is third position, this is fourth position. Okay, I want a node to be created at third position. So this is first, this is second, this will be third, this will be fourth, this will be fifth. Okay, so how can I insert this node at the third position? So for inserting a node at the nth position, I have to be at the n minus 1th position. Okay. The reason behind this is that I want to create this node. This node is linked with this. If I create this node at between these two nodes, okay, then I have to link this with this and this with this, so that the linked list will be created and its property will not be violated. Okay, so what happens here? First of all, a linked list is created, its data part is created, right? Now if I want to go here, how many traversal I have to do? I want to insert a node at 3rd position. I am currently at 1st position. So I have to go to the 2nd position because I want to insert the new node at the 3rd position. I said now, for inserting at nth position, I have to go to the n minus 1 position. So for going to the 2nd position, I have to move one time. If I want to insert a node at 4th position, then I have to go at the 3rd position, and for reaching the 3rd position I have to traverse one time, two time. If I want to insert a node at 5th position, then I have to go to the 4th position, and for going to the 4th position I have to traverse 1, 2, 3 times. That means I have to traverse n minus 2 times. Got it? I have to traverse n minus 2 times. So this is the logic behind the insert at nth position mechanism. So we have the position number. Okay. Now for I in range position minus 2. For I in range position minus 2. Okay. What will I have to do? First of all, I have to go to the current node. That is the first. I have to go to the first node. So I can go here by using current node equals to self dot head, right? By this, now I have reached the current node, that is first. Okay. Now, if position equals to 1, if it is 1, then what I have to do? Insert at head. If I am at first position, then why will I traverse? Okay. Why will I traverse? I don't have to traverse. Then simply node. Okay. Node, and before that, node dot next equals to self dot head. Why I have written this? Tell me why I have written this. I want to insert at the first position. So for inserting at first position, I have to first put the reference of the first element which reference is stored in the head variable. Okay. And then head will point to the new node. If this is not true, okay, if this is not true, else current node will be referenced by the is referencing to the first node of the list. Okay, now current node equals to current node dot next. Okay, so by this I will reach to the n minus 1th node. I will reach to the n minus nth node, and then node dot next will be current node dot next. Why it will be like this? See, I am here. Okay, currently this node links to this. If I want to insert a node between this, then I also have to link this with this now. Currently this is also referencing this, no problem. Okay, I will come to that. First of all, I have to reference this. That's why I have written next node, sorry, new node, that is node not next equals to current node dot next. That means the new node's next variable will refer to the current node's next variable, next node. Okay, now current node dot next equals to node, simply. So this 2000 that was referenced this node, now it will refer to the new node. We can also check this, print to insert nth, to insert at nth, elif ch equals to 4. Now position equals to input, enter the position. After that, link dot insert nth position, and in this we will take a input. Okay, so now I'm displaying the content first to, okay, it is none. Then I am inserting at first position, the number is 5, displaying 5 has been inserted. Then I am inserting 2 and I'm giving 8. Now see, in second position 2, okay, sorry, I have inputted wrong. I have entered the choice 8. That was the invalid choice. That's why I have to input our choice, input my choice again. So I have inputted 2 and it is displaying. Now I am entering again 4. Position, I'm giving the position number 2 and the number to be inserted 8. And now I'm displaying the content. You can see that at second position 8 has been inserted. Now see 11. It will be inserted at the end position 5, 8 to 11. Okay, now I am giving 4 and giving the input at the position number 3. That means currently at position number 3 2 is present, so 2 will be shifted, this shifted. I am entering 10 So now see 5, 8, 10 to 11. So my insert at nth position also works. Okay, now there is a disadvantage. There is a flaw in this function of insert at nth position. What happens if my list contains only 2 elements and I insert a node at position number 10? Can we do it? Does position number 10 exist? No. So I have to check this. So for that, I am writing a function to count the number of nodes. This function will be same as the display function, and here instead of printing the values, I have to increment the count of the nodes. Okay, so this count function has been written. We can also check this count function whether it is working or not. 5, if I input 5, then we have to call the count function. Now suppose I'm entering 10, 20, now I'm putting 5. So is there any error in this code? Yes, again it is C. Again it is not traversing. Again it is not traversing. So this line will be must here also. Now running this code, counting. Okay, so I am not printing the values, so I have to print count is if ch equals to 0. What happened? L if ch. Okay, wait, there is, okay, so there is a missing parenthesis. Now I am counting. It is showing count equals to 0. I am inserting a node. Now it will show count equals to 1. Again inserting a node, it will also now show count equals to 0. So my count function works. Now I have to restrict this position in the illegal position number na. So what we'll have to do in this case, I have to check. Here I am inserting position number na. If position number greater than 0 and position number is less than link dot count, okay, plus 1. If it is so, then only it can be inserted, else print out of bound position. Okay, see why I have written this. What happens if I put position number -1? Does position number -1 exist? No. Okay, so if my list have two nodes, okay, if my list have 2 nodes, if I want to insert a node at the position number 3, then it can be inserted na at the 3rd position. So that's why I've written count plus 1. Okay. So this has been done. Now we will write some function for deletion operations. Okay, so I have to now write the function to delete the node at the beginning. So delete beginning self. Okay, delete the, I have to now delete the node from the beginning. Okay, so what I have to do? First, I have to check if the list is empty or not. If the list is empty, then I will delete whom. So first, if self dot head is none, then print linked list is empty. Okay, else I have to delete first element now. So I am putting the first element in the current node. Okay, and cell and putting the head pointing to the second node that will be in the current node dot next, and then delete the current node. Okay, so by this delete at beginning function will work. Just think logically. If this is a node, this is head. Okay, there is also another node. Okay, this head is pointed here, this node is pointing here. I have to delete the first element of this node. Then what I have to do, I have to refer this head this first node by a I am referring this first node by the current node variable. Okay, and then current node next will point is referenced by the head, and then we are deleting this. This can be done now. So I'm written this. Now see the function delete a node at end. Okay, so delete end. Okay, again we have to check if self dot head is none. Okay, then print empty, linked list is empty. Else what I have to do, I have to go to the last node. So current node equals to self dot head. Okay, I have to go to the last node or first node or last minus one node. Say, what does your logic say? See, if I have to delete the last node, okay, so what does its previous node will contain in its next field? Just think about this. If this is a head, this is a node, this is a node, this is a node. Okay, this is linked here, this is linked here, this is linked here. Okay, if I want to remove this node, Okay, then will I go here or here? I have to go to the its previous node. Okay, then I have to put none in its previous node, and then we have to delete this. Okay, so I will how I will go to there? Just think. While current node dot next, while current node dot next is not none, traverse. Okay, traversing will be done. Okay, current node dot next is not none. If it is so, no. Just think logically. Current dot now node dot next, it is not none. So the cursor will move to here. But I don't want to go here. I want to go in its previous node. I want to stay here. So I have to check current node dot next. Dot next is not equals to none. Okay. Then I am in the current node dot next. That means second last node of the linked list. I am in the second last node of the linked list. Okay. Now, what will I do? Node equals to current node dot next. I will store the node to be deleted in a temporary variable, and then current node dot next equals to none and delete node. Got it? This is the way to delete a node from the end position. Now there can one more conditions here. That is, what if the linked list has only one element? Okay, so if self dot head, if self dot head dot next is none, okay, then what I have to do? Move this, okay, here. I have to modify this program accordingly. Now we will see, we have to do current node. If current node dot next is none, that means that linked list has only one element. So now delete the current node and store none in the head. Okay, store none, or simply you can also store current dot next node dot next before this. So there can be these conditions for the deletion from a linked list at the end position. Okay, so there can be these conditions. Now deletion from the nth position, and this will be our last function. Function to delete a node from nth position. I am going a little bit fast because I've already explained the logics of this end, beginning, and end positions while discussing the insertion operations. So same logic will be applied for the deletion operations, but you have to think logical, think yourself, draw the node diagram, then you will be you can understand these things. So now def delete nth self position. Now I will take a position from the user. Now if self dot head is none, that mean again linked list is empty, right? Else I have to delete the nodes. Current node equals to self dot head. Okay. Now if position equals to 1, same logic which we are implemented in the insertion at nth position will be implemented here. Okay. So now self dot head equals to current dot node dot next, and then delete the current node. So by using this, we can delete the node at the first position. Else we have to go to the position minus 2. We have to traverse position minus 2 times. So for I in range position minus 2, okay, while current node dot next. Here also we have to put next because we at this time we have to be at the n minus 2th position. Same logic which we discussed in the delete at end position, that we have to check whether I have reached to the node and the node which has to be deleted, I have reached before it. Okay. So while next current node dot next is not none, okay, then traverse current node equals to current node dot next, and then coming out from the for loop, node equals to current node dot next. Okay, set the node to be deleted at the node variable, and now I am putting current node dot next equals to node dot next, and then delete current node. So see why I have written current dot next equals to node dot next, because we have a node. Suppose a scenario in which I have a node, this I have this node, I have this node, and I want to delete the second node. I am currently here. Okay, I am currently here. Okay. Now I have taken this node in the node variable. Okay. So I have to link this with this now. It's and this third position node's address is where it is here now. Okay. So this is the, that's why I have written this. So that's why this has been written there. Okay. Now all our functions, necessary functions has been implemented. Okay. Now here it will be delete the node, because the node which we have temporarily stored, that will be then deleted. Okay. So now print 6 to delete from beginning. Okay. Then end, then nth. Delete from n and delete from nth position. Then 7, 8. Then elif ch equals to 6. Then link dot delete beginning lf 6 equals to 7. Then link dot delete end elif ch equals to 8. Then I have to input the position number, input, enter the position. Then if position greater than equals to 0, greater than 0 and position less than link dot count. Okay, then only it can be deleted. So link dot delete nth position. Okay, else out of bound position. Okay, so I have completed my menu driven program. Now I will check each and every functions for the last time. First of all, display. The list has no items. Okay, that's why it is displaying none. Now I am inserting at beginning 10, 20. So 20, 10 is inserted. Now I am inserting 30 at the end position. So see, 30 has been input assigned at the end position. Now I am inserting 25 at the second position. Position number 2, 25. So see, 20 then 25. So 25 has been inserted at the position number 2. Now I am deleting from the beginning. Okay. So for deleting, I have to enter 6. So 20 should be deleted. Yes, 20 has been deleted. Now I am deleting from nth position the second variable, second position, that is 10. Okay, 10 has also been deleted. Now the last one, that is end. So previously it was 30 at the end position. Now 25 is there only, and now 5. So count is 1. So my all the functions are working properly. So this was the implementation of linked list in Python. We can similarly implement linked list in C language, C++ language, Java language, okay, any kind of language. Just we have to keep in mind that logic is important, and logic is nothing but the way you practice yourself. Linked list, I will suggest to draw each and every diagram of each and every functions in your copy. Then think about the logic, how it can be implemented, how it can be improved. Okay, keep in mind the time complexity of each and every functions. Okay, so thank you.